Here we are again in West Virginia. Isn't it great? And speaking of great, the great thing is joke of the day, because joke of the day is like the best way to start the day. Are you ready? Let's do it. So how does Moses make his tea? Well, he brews it. Moses is Hebrew. Anyways, let's take a look at even and odd function. I was trying to make a joke out of even and odd functions. There's no joke there. Anyways, we're going to take a look at even and odd functions today. Now, what even and odd functions do is they identify graphs that have symmetry. So when we talk about symmetry, we talked about that before. That's the idea of being able to fold on top of itself. So if a graph has symmetry, then that means this side of the graph will fold right on top of this side of the graph and completely go right over top of itself. So what happens is, if you have an even function or an odd function, then you do have a graph that has symmetry. But each one has a different type of symmetry. Now, to determine whether or not your graph is even or odd, without even looking at the graph and simply looking at the function itself, in other words, the equation, what you do is you take the function and everywhere you see an x, you put a negative x into the function everywhere you see an x. And that's the case whenever you're trying to determine whether or not you have an even function, or if you're trying to determine whether or not you have an odd function. Same situation, you're going to take your function, you're going to put a negative x everywhere you see an x. And then once you plug that negative x in everywhere you see an x, you're going to follow the order of operations, which says do your parentheses first, then do your exponents, then do any multiplication division together as a group working from left to right. And then take a look at your addition and your subtraction. Again, working as a group from left to right. And then what happens is, once you do all that order of operations, if you come out with exactly what you had when you began, your function is completely, totally the same, exactly the same, then you have an even function. If you come out with the opposite of what you had before, in other words, every single term is completely the opposite of the term that you had before, that would indicate that the signs are different on every single term, and you have completely the opposite, then you have what's called an odd function. So it goes exactly, even, opposite, odd. They've got the same letter in the beginning. That's a great way to remember this. Now, if you have an even function, then that means that your graph has symmetry with respect to the y-axis. Now recall, your y-axis is that vertical axis that goes like this, and so if it has symmetry with respect to this axis, then that means it's going to fold on top of itself over that y-axis. This side here will fold across that y-axis like this, or vice versa, this side here will fold right over top of the y-axis like this. Now, if it's an odd function, then you still have symmetry, but not the same type of symmetry. You have symmetry with respect to the origin. Now, respect with the origin simply means, okay, here's my 2D coordinate plane. My origin sits right here where the two axes cross. So if I have symmetry with respect to that origin, what that means is I'm going to put a pin right there at that origin on the graph. And then what happens is, as I spin the graph around that 2D coordinate plane through that pin, it's going to fall right on top of itself. Now, doing a full 360 does not create symmetry with respect to the origin, because every graph will roll on top of itself across that, or around that origin doing a 360. That stands to reason. But if the graph can go like a 180 basically and fold on top of itself, then it has symmetry with respect to the origin. The ways to remember it are opposite, odd, origin. Big 3 O's right there. Matter of fact, I really ought to put this in caps so that you can see that. The big 3 O's, opposite, odd, origin. So if I come up with the opposite of what I had before, it's an odd function. If it's an odd function, it has symmetry with respect to the origin. Here, exactly, even, and y-axis symmetry. I got nothing there. I don't know. But anyways, I got the two big E's right here. Exactly, even, and if it's an even function, then I have symmetry with respect to the y-axis. So let's take a look at some examples here. And I've got 3 of them. So in my first example, and all 3 of these, I'm going to determine whether or not the function is even, odd, or neither, because it is possible that it's none of them. It's neither even nor odd. It's not exactly the same, nor is it completely the opposite. It is possible to have a mixture of the both. And if you have a mixture of both, then that means it's neither. And so if it's even or odd, then we're going to tell the type of symmetry. So take a look at my first example here. Here's my function f of x, and this right here is the function itself. So to determine whether it's even or odd, all I'm going to do is take this function, and everywhere I see an x, I'm going to put a negative x in its place. So I see an x right here, I'm going to put a negative x in there, and then I'm going to cube it. I see an x right here, I'm going to put a negative x in there. And so like I said, at this point you follow order of operations, which says parentheses would come first, but I don't have any big grouping symbols in there. So exponents would come next. A negative x to the third basically means a negative times a negative times a negative, which an odd number of negatives comes out as negative, so it's a negative x to the third. And then here, subtracting a negative is really adding a positive, so this is my ending function. So what I do is I take my ending function, I compare it with my beginning function, and I say, is it exactly the same? In other words, is this term exactly the same? Is this term exactly the same? No, they are not. In fact, this one became completely the opposite when it became a negative. This one became completely the opposite when it became positive. So therefore, I have opposite here. When I have opposite, then that indicates that I have an odd function. And recall that odd function indicates that I have symmetry with respect to the origin. So there is my second part of my answer. Symmetric with respect to the origin. Now incidentally, just to give you a visual of what that would look like, these types of functions, your cubic functions, they make these little Nike swoosh kind of pictures. So a cubic function is going to look like this. And you can see, yes, in fact, what I was describing about putting a pin right here at the origin. And you can see this function. If I would put a pin here and spin it around that pin, this part up here would spin right down there. And this part down here would spin right up there. And so yes, that does create symmetry with the origin. This does make sense. Now, let's take a look at the next example. Once again, to identify whether it's even, odd, or neither, what I'm going to do is take the function g of x, and everywhere I see an x, I'm going to put a negative x in its place. So I'm going to put a negative x here, and I'm going to put a negative x here. And then I'm going to follow the order of operations to evaluate that. There are no parentheses in there, big grouping symbols, but I do have an exponent here. So once again, this indicates a negative x times a negative x. That's an even number of negatives, making it positive, so it's a positive x squared. And subtracting a negative is really adding a positive. So here is my ending function. I'm going to compare this ending function with the beginning function, and I'm going to say, is it exactly the same? Well, these two terms are exactly the same, but these two terms are not. It started as a negative, now it's a positive. So it's not exactly the same, nor is it completely opposite, because these two are opposites, yes, but these two are not opposites. It has to either be exactly the same, every single term, or totally opposite, every single term being opposite. This is a combination of neither one of them, so my answer here is going to be that it is neither even nor odd. And when it's neither even nor odd, then it might have symmetry, but it doesn't have the two types of symmetry that I'm talking about. It definitely does not have symmetry with respect to the origin. Definitely does not have symmetry with respect to that y-axis. Incidentally, this particular graph, again, just to get a visual of what's happening here, it is squared, so it's a quadratic. You guys are familiar with quadratics. You know how to graph those. This particular quadratic is going to have a vertex sitting right about here, and it's going to go right about like this, right about like this. It does have symmetry, no doubt about it, because here is that axis of symmetry. All quadratics have axis of symmetry, definitely. So this one will fold on top of itself, but again, the idea is it symmetry with respect to this y-axis? Is the y-axis your folding line? No, it is not. So it does have symmetry, but not the kind of symmetry I'm looking for. All right, now the last one. Once again, to find out if it's even, odd, or neither, take my function, my h of x, put a negative x in its place. And so what I'm going to do now is put my negative x in here, and then I'm going to square it. Put my negative x in here, and then do the fourth power. And so once again, follow order of operations. There's no big grouping symbols for parentheses. I do have exponents here and here. This exponent means negative x times negative x, which is positive x. So I end up with a 2x squared. And here, negative x to the fourth. Again, that's an even number of x's indicating positive. So I get a positive x to the fourth. So here is my ending function. I'm going to compare that with what I started with, and you can see these two terms are exactly the same. These two terms are exactly the same. So it is exactly the same, exactly even. So this is an even function. And recall that when it comes to even functions, what type of symmetry do they have? That is symmetry with respect to the y-axis. So it is symmetric. Whoops, having trouble writing here. With respect to that y-axis. Now again, to get a visual of that, this particular type of graph, my fourth power, and this one will look like this, and it will fold right on top of itself. Now fourth powers usually make a W, but this W is kind of extending up a little bit. So fourth power will flip right over top of itself, and you can see, yes, there is that symmetry across that y-axis line. So hopefully this helps you to understand your functions, whether you're looking for even or odd. And as we stated before, all you have to do to figure out whether you have an even function or an odd function is to simply take your function, put a negative x everywhere you see an x, follow that order of operations, and then compare your result to what you had before. If you have exactly what you had before, exactly even means symmetric with respect to the y-axis. If you have the opposite of what you had before, opposite odd, symmetry with respect to the origin, the big three O's. So I hope that helps. Have a fantastic day.